You know that sinking feeling when you're setting up a home theater or maybe a conference room and you realize the display is just 10 feet too far for a standard HDMI cable?
Oh, yeah. You either get that awful digital sparkle or the screen just goes completely black on you.
The classic distance limit. Physics is just a harsh mistress when it comes to copper cables. You want the bandwidth, but you lose.
Lose the distance, exactly.
Right, so today we're looking at a solution that stops fighting physics and starts using your network instead. We are doing a deep dive into the product page for the Zenty ZT-332 IP400 AV over IP system encoder, specifically the unit from HDTV Supply.
And our mission here is to unpack what swapping HDMI for Ethernet actually means for your setup and why the specific specs on this unit, like the somewhat cryptic 4.4.4, really matter in the real world.
So let's look at the big picture first. This Zenty unit is an encoder, meaning it sits at your source, like your PC or Blu-ray player.
Right, and instead of sending a raw video signal down a dedicated cable, it converts everything into data packets.
It basically tricks your video source into thinking it's hooked up directly to a TV, right?
Exactly. But it's really broadcasting that data over a standard Gigabit Ethernet network.
Which completely changes the distance game because we aren't talking about 50 feet anymore.
Not at all. Over a single cheap Cat 5e cable, which is probably already in your walls, yeah, you can push a full 4K signal up to 330 feet. That's 100 meters.
Just point to point.
Right. And if you add a standard network switch into the mix, you can go even further.
So that's the IP part of AV over IP, but I want to challenge you on the quality here. Usually when we compress video to send it over a network, we lose something.
That's a totally fair point.
The specs here claim 4K at 60 Hz with 4.4.4. Why is that specific number such a big deal?
It's all about chroma subsampling. Basically, an image is made of brightness data and color data. Streaming services and even Blu-rays throw away half that color data to save bandwidth, which is 4.2.0.
Which is fine for a movie, I guess. I mean, I probably wouldn't notice the difference in a fast explosion scene.
Yeah, you wouldn't. But if you hook up a PC and try to read red text on a black background or look at a really complex Excel spreadsheet, that 4.2.0 looks fuzzy. The edges bleed.
So this Zenty unit doing 4.4.4 means it keeps all the color information intact.
Exactly. It is pixel perfect.
So for digital signage or a command center, that's practically non-negotiable. However, I did spot a caveat in the documentation regarding HDR. It supports Dolby Vision and HDR10, but there's a catch.
A pretty big one, actually. It's not automatic. You have to go into the settings and switch the HDMI timing hybrid to pass-through mode.
Pass-through mode, got it.
Right, because if you leave it on the default, you might actually be stripping out all that high dynamic range data without even realizing it.
A classic read the manual moment. Now, we've covered the video, but a home theater isn't much without sound. Did they cut corners on the audio to save bandwidth for that uncompressed video?
Surprisingly, no.
Yeah.
It fully supports PCM 7.1, Dolby Atmos, and DTS:X.
Wow, so if you're building an immersive sound setup, this encoder handles those high bandwidth audio streams right alongside the video.
It does. It's a really robust solution.
Okay, so it looks good and sounds good. But here is where it gets practical for me, KVM. The specs mention roaming and USB extension.
This is huge for usability. KVM stands for Keyboard Video Mouse. Because this encoder sends USB signals alongside the video, you can have your noisy, heat-generating gaming PC in a closet somewhere.
And you can just sit in a perfectly silent room 300 feet away with just a monitor and a mouse.
Exactly, and it feels instant. The
Yep.
latency is low enough that for general use, you would never know the computer wasn't right into your desk.
That flexibility scales up too. The source material mentions you can actually use these to build video walls.
Massive ones, yeah. Up to 16 by 16 screens. Because every screen has a decoder and every source has an encoder, the network switch acts as a massive matrix.
So you can route any source to any screen or stretch one single image across all of them.
Which totally beats buying a dedicated, clunky matrix switcher that takes up half your server rack.
Now, before we wrap up, I saw this unit has two ways to connect. A standard 1G base T copper Ethernet port and a 1G optical port.
Yes, but there's a gotcha there you need to know about.
I had a feeling.
Usually with copper, people use PoE, or power over Ethernet. You don't need a power brick because the switch powered the unit. But if you use that optical port for a fiber connection, well, fiber cannot carry electricity.
So you actually need to plug it into a wall outlet.
You must use the included power supply for both the encoder and decoder. It sounds obvious, but it's really easy to forget when planning your cable runs.
Good catch.
Yeah.
So to summarize, we have a device backed by a 5-year warranty that replaces limited HDMI runs with scalable long-distance networking.
It keeps the text crisp with 4.4.4 color and handles full Atmos audio, but it does require a manual toggle to get your HDR working right.
It really represents the convergence of AV and IT. Video is just another data packet on the network now. Which leads to a fascinating thought to leave you with today. If we can route uncompressed 4K and control our computers from literally anywhere in a building using standard internet cables, does the physical location of our hardware even matter anymore? Are we finally entering the era of the invisible computer?
We just might be.
Thanks for joining us for this deep dive.